Unit 34, Section 1. Variation of functions. Okay, before we get into what this lesson is about, we need to talk about the right triangle and the sides that we have. We have the adjacent side, the opposite side, and the hypotenuse. Okay, from now on, we're going to call the opposite side the y side. The adjacent side is going to be the x, and the hypotenuse is going to be r for the radius. So if we take a look up here, we have an angle inside of a circle, and this is our xy plane right here. We're always, so far anyway, we have always been talking about the first quadrant triangles. So here we have a right triangle drawn with the reference angle at the origin. Okay, and so the opposite side over here is along parallel with the y-axis, and the adjacent side right here is on the x-axis. And the hypotenuse will be the radius of the circle. So as we move it around the whole circle, the hypotenuse is the radius. The radius of a circle is always considered positive. Now, the y and the x values can be negative or positive, and we'll talk about that in a little bit more detail in a little bit. But the radius, or the hypotenuse, will always be positive. So down here we have the reference angle here, the adjacent side, the opposite side, and the hypotenuse. Now, I want to talk about fractions as well, increasing fractions and decreasing fractions. So if we have a fraction, and let's start it out at 4 over 8. And then if we keep the denominator the same and we increase the numerator, let's say from 4 to 5, so 5 over 8, and then 6 over 8, and then 7 over 8, as the numerator increases, the whole fraction increases. The same is true as if we decrease the numerator. Well, not the same thing, but it follows the numerator if the denominator stays the same. So if we go from 4/8 to 3/8, 2/8 to 1/8. If we decrease the numerator, then the fraction goes down. So let's take a look up here at our angle. So far, if we start at this angle, it's approximately 45. We have a certain ratio that matches that reference angle. Now, if we increase the reference angle, we can see right here that the y side, or the opposite side, gets closer and closer to what the radius is. So we know that sine is the opposite over the hypotenuse, and we're just going to say y over r. If we increase the y and draw it closer and closer to r, that means that sine is increasing. At the same time, we have the cosine is the x, or the adjacent side, over r. And the adjacent side here, the x value here, as we increase this angle up, is going down and down. As we get closer and closer to 90 degrees right here, the adjacent side goes down. So that means that as we increase the angle, cosine goes down. And if we actually make it to 90 degrees, so if this angle right here, this reference angle, actually gets up to 90 degrees, that means that the opposite side, or the y side, will actually be right on the radius, right up there. So what we would have, we would have the sine of 90 is equal to, if these two are the same, then I can draw it like this, radius over radius, and anything that is divided by itself is equal to a 1. So the sine of 90 degrees is equal to 1. Now remember, before I said that the sine will never be more than 1. I didn't say it couldn't be 1. I said it won't be more than 1. Now let's take a look at what happens to cosine in this situation. As this angle keeps getting closer and closer to 90 degrees, and once it reaches 90 degrees, there will be no adjacent side. So the cosine of 90 degrees is equal to, and as our numerator goes away, it becomes 0. And 0 divided by anything is 0. So the cosine of 90 degrees is equal to 0. So as we're approaching both, we'll talk about 0 degrees over here, but as we approach 90 degrees, this is what happens to sine and cosine. Cosine goes to 0, sine goes to 1. Now let's take a look at this situation over here. Break it down. Okay, so here we have, if we talk about our reference angle over here, the one we started with right there, and as we decrease that, take a look at sine first. Sine, as we decrease our angle, sine is y over r, and as the y value starts to go down, that's the numerator, sine starts to decrease. And cosine is x over r. As we decrease our angle, our opposite or not our opposite, but our adjacent side gets bigger and bigger, gets closer and closer to what r is. So as that happens, cosine goes up. So let's see what happens when we take it all the way down to 0. So as this angle becomes 0, then that means that the radius is now the same length as the adjacent side. So that means that the cosine of 0 degrees is equal to, now the radius and the adjacent side will be the same, so I'll just say r over r. So that is 1. So the cosine of 0 is 1. Now sine, we have our y side right here, as that becomes 0, so the sine of 0 degrees is equal to, the opposite side goes away, so that would be 0 over r, so that means 0. So here's our two extremes, 90 degrees and 0 degrees. So the sine of 90 is 1, cosine of 90 is 0, cosine of 0 is 1, and the sine of 0 is 0. Okay? So that's what's being talked about in this lesson. So let's take a look at page 854. And they kind of sum it up right there in the table that's right in the middle, figure 34.2. It says, sine increases from 0 to 1 as an angle increases from 0 to 90. That's the heading of the table. So sine increases from 0 to 1, and then it says tangent increases as well. We didn't talk about tangent. Cosine decreases from 1 to 0 as we're going from 0 to 90. So cosine will go from 1 to 0. Okay, we haven't talked about tangent yet. Okay, so tangent is equal to y over x. Okay, so this is my y value, this is my x value, and there's the angle. So when we're at 45 degrees, we have the same y and x value, so they're the same. So the tangent of 45 is equal to this over that, so I can just say that it's the same. It's like saying 1 over 1, which is equal to 1. So at 45 degrees, tangent is 1. Okay? So as we increase the angle from 45 going towards 90, okay, what's going to happen here is we have the tangent of going towards 90 is going to be equal to y over x. And we know that as the angle gets to 90 degrees, we have the y value approaches r, or becomes the same as r, and the x value goes to 0. Well, you can't have 0 in your denominator, okay? Now, we talked about fractions a few minutes ago, and I only talked about the numerator, but let's talk about the denominator for a moment. If the denominator in your fraction gets closer and closer to 0, so for example, let's say we've got 8, and let's start with 4 in the denominator. And as we go from 8 to 3, and 8 to 2, and 8 to 1, you can see it's decreasing all the time. So if my numerator stays the same, and my denominator, or actually the numerator doesn't have to stay the same, but if the denominator approaches 0, so we can conclude that if we take 1 and keep going all the way to 0, we're going to increase the fraction. So the fraction is increasing as we go. So if you've ever studied limits, you'll know that when your denominator approaches 0, it can never become 0 because you can't divide by 0, but as it approaches 0, the fraction goes up, okay? So as the tangent, as the tangent approaches 90, I'll just draw an arrow like that, approaches 90, that tangent gets closer and closer to positive infinity, and that's a terrible way to write infinity. Okay? Now, let's look at over here. As tangent gets closer and closer to, so we start out with tangent is y over x, and as the angle gets lower and lower, closer to 0, we know that the x side then becomes r. So we'll say tangent of, we know that r is in the denominator, and the y side becomes 0. So the tangent of 0 degrees is equal to 0 over r, which is going to be 0. So we can say it like this. As tangent goes from 0 to 90, then tangent will go from, or as the angle, I'm sorry, I said that wrong. As the angle goes from 0 to 90, tangent goes from 0 to infinity. All right? So, and that says, it talks about that on page 854, figure 34-2, right in the middle. Okay, it says sine increases as you go from 0 to 1, or it says right there, as angle increases from 0 to 90, sine increases from 0 to 1, cosine decreases from 1 to 0. That's what we talked about a few moments ago. And then tangent increases from 0 to infinity as the angle goes from 0 to 90. All right. Now it also talks about secant, cosecant, and cotangent, but we don't need to talk about that right now. That's different. You can just simply invert the rest. Now remember, whenever you get to 0 in your denominator, that is approaching infinity. Approaching, not becoming, but approaching. So let's take a look at some of these questions on page 855, 5. I gotta have my glasses on to see that number. Okay, let's just pick one, number 11. Now the figure that we're looking at is 34.3. It says, when side y equals side x, or side x equals side y, what is the value of angle 1? Well, we just talked about that right there. When the two sides are equal to each other, I'm talking about the x and the y side, that's an angle of 40. So it says, what is the angle 1? It's 45. What is the value of the tangent function? So the tangent of 45 is 1. We talked about that. And then it says, what is the value of the cotangent function? Well, 1 over 1, and you invert that, you get 1 over 1, which is the same thing. 1. Okay, let's see if there's another one in here. So let's look at number 13. When side y equals side r, that's like this right here. Oops, down a little bit. What is the value of the sine function? So remember, that is when y is going to actually equal r. So that would be a 90-degree angle. And so that would be, it says a is what is the value of the sine function, sine of 90, which is going to be 1. Sine of 90 is 1. B says what is the value of the cosecant function, and that would also be 1, because cosecant is the inverse of sine, so it would just be 1 over 1. This is what is the value of the cosine function. The cosine of 90 degrees is 0, because you don't have any adjacent side anymore. And then the D says what is the value of the cotangent function. So that would be the same as the tangent of 0. So the cotangent of 90 degrees would be 0, because tangent is y over x, which is approaching infinity. So if we invert that, we get 0. Don't really worry about, I don't put those cotangent and cosecant and secants on any tests or any quizzes. So if you didn't understand that, that's not that big of a deal. All right, so let's take a look at page 856. For numbers 15 through 24, it says, for each exercise, functions of the two angles are given. Which functions of the two angles is greater? Do not use calculate. Okay, so let's go to number 16. So we're comparing sine of 38 to sine of 43. The sine of 43 is greater than the sine of 38, because remember, when we go from 0 to 90 degrees, we're increasing the sine function. And then number 17 says the tangent of 17 versus the tangent of 18. As we increase our angle, the y value increases compared to the x value. So the y value is in the numerator, so the numerator is going up and the denominator is going down, so that means it goes up. So the tangent of 18 is greater than the tangent of 17. Let's see, let's find out. Number 18 is a cotangent, or cosine rather, sorry, cosine. Oh, so we've got cosine of 53 versus the cosine of 61. Now remember, as the angle goes down, cosine goes up. So that would mean that the cosine of 53 is greater than the cosine of 61.